Good morning, it's May 5th, Cinco de Mayo. This is Math 1 second semester final review. I'm going to do the odd numbers for Unit 5 right now. So, number 1, simplify so there are no exponents. Alright, so a negative exponent means put it on the bottom and make it positive. We have to leave something up top, so we leave a 1 up top and 1/5. Anything to the 0 power equals 1. Okay, this is 4 times 2 to the negative 3, so the 4 stays on top, 2 goes to the bottom and becomes positive. Well, 2 to the third means 2 times 2 times 2, or 8, so this is 1/2. Alright, first we simplify our parentheses. 4 times 2 is 8, so this is 8 to the negative 3, which becomes 1 over 8 to the third. This is 8 times 8 times 8, and so we get 8 times 8 times 8, which is 512. So this is 1 over 512. Alright, I'll leave number 2 for you to do. It's all about the set of numbers. Remember, you have the integers, you have rational numbers, you have irrational numbers, and you have real numbers. Alright, let's go on to number 3. Man, looks like I'm doing all the heavy lifting today. Alright, so f of x equals 2x, so our slope is 2. Remember, y equals mx plus b, and in this case b is 0. So we have, I'm going to find a straight edge really real quick. I can't find my straight edge, so I'll have to use Barnes & Noble card. So we have a y-intercept of 0 and a slope of 2, which means rise 2, run 1, rise 2, run 1, and we end up with this line right here. Remember, make your lines go all the way across your graph. Okay, that's an exponential, and g equals 2 to the x, so when x is 2, that would be 2 to the second power, or 2 squared, which is 4. 2 to the first would just be 2. 2 to the 0 would equal 1. 2 to the negative 1 would mean 1/2. And 2 to the negative 2 would mean 1 over 2 squared, or 1/4. Okay, so when x is 2, g of x or y is 4. When x is 1, g of x or y is 2. When x is 0, y is 1. When x is negative 1, y is 1/2. And when x is negative 2, y is 1/4. So we'll just kind of guess at it right there. And we have this exponential function right here. So it is a curve that is approaching 0 but will never reach 0. 1/4, 1/8, 1/16, 1/32, 1/64, 1/128, 1/256, 1/512. Just keeps getting closer and closer to 0, but it'll never quite reach it. Alright, let's move on. So what you notice here is we have g of x equals 2 to the x. Here we have h of x equals 2 to the x minus 3. So basically it's the same, except after we raise 2 to the x power, we subtract 3. So when x is 2, h of x is 4 minus 3, or 1. Okay, when x is 1, okay, we have 2 to the first, which is 2 minus 3, which is negative 1. When x is 0, we have 2 to the 0, which is 1, and 1 minus 3 is negative 2. When it's negative 1, we have 2 to the negative 1, which means 1/2, and this is where it gets a little weird. 1/2 minus 3 is negative 2.5, so it'd be right here. And then negative 2 means 2 to the negative 2, which is 1/4, and 1/4 minus 3 is negative 2 3/4, and we end up with this graph right here. And basically it's the same graph. All we did is we moved it down. We just moved it down 3 spaces. Everything went down 3 spaces. Okay, I'll leave number 4 to you. Number 5. Tell whether there are no real solutions or one real solution, no real solutions, or infinite many solutions. Alright, so we need a little extra paper here. So let me get a piece of scratch paper here. Alright, so here's what we're going to do on number 5. Remember, we have to get both sides of the equation to the same base. So can we rewrite this side to 2 to some power? So 2 to the x equals, well, 8 can be written as 2 to the third, because 2 to the third is 2 times 2 times 2, which equals 8. When we get the same base, we can actually ignore the bases, and x equals 3. So there is one solution here. Alright, B. Alright, can we rewrite this side so that -7 is 3 to some power? No, we cannot. So there are no solutions. There's no way to rewrite -7 as 3 to some power. Okay, let's go on here. Okay, 1/3 to x equals 0. Alright, so if we simplify this, this is 1/3 equals 1. And 1/3 will never equal 1, so we can just say no solutions. Okay. Alright, and finally D, well, we have 25x equals 5 to the 2x. Well, let's see. 25 can be rewritten as 5 squared, right? Because 5 squared equals 25 to the x, which equals 5 to the 2x. And we get 2x equals 2x, which means infinite solutions. All right, moving on. Number 6 is for you guys to do. Number 7, find the average rate of change of k of x for x equals 0 to 3. Okay, well, here's x equals 0, and here's x equals 3. So we would say, remember, the rate of change or slope is delta y over delta x. So this guy is 3 minus 0. I'm sorry, nope. Here's my y's down here. Sorry. It's 17. Let's redo that. 17 minus 5 over 3 minus 0. 17 minus 5 is 12. 3 minus 0 is 3. So our slope, I'm going to write it up here, is equal to 4. 12 divided by 3 is 4. Okay, m of x equals 5 to the x for x equals 1 to 4. So we have to find the slope. So remember, we're still going to use that same formula. M equals y2 minus y1 over x2 minus x1. But first we gotta find out what the y value is when x equals 1. So that means we're going to find m of 1. Instead of x, we're going to replace it with a 1, which means 5 to the first. So when x equals 1, y, or m of x, equals 5. So we have 1, 5. And when x equals 4, so m of 4 equals 5 to the fourth. Okay? And that means m of 4 equals 5 times 5 is 25, times 5 is 125, times 5 is 625. So we end up with 4, 625. So now the slope here is, let's go back over here, using the slope formula, it's 625 minus 5 over 4 minus 1. So we end up with 620 over 3, and that won't go in evenly, so we'll just leave it as that. Okay, number 8 is yours. Number 9. John invests $1,000 in a savings account paying 8% annual interest. Write an equation that models the amount of money he has in the account after X years. That's pretty easy. That's one of our simple interests. So his amount is 1,000. That's his beginning, times 0.08. That's his growth factor, to the X. Now I left off one thing. Remember, at the end he's still going to have that $1,000, so we need a 1 there. So it's P equals 1,000 times 1.08 to the X. The 1 represents the 1,000 he starts with. The 0.8 represents the 8% of interest he's going to earn. And how much money will he have in the bank after 10 years? Well, we can put that in our calculator here. So we'll go 1,000 times, I like to use parentheses, and we're going to raise it, that arrow up button, to the 10. And what do we get? We get $2,158.92. Alright, I'll leave number 10 for you. Number 11. Algebraically solve for X and check your answers. Alright, so again, this is, we've got to get both sides of the equation to the same base. Here's the easiest way for you guys to do this. We know we want a base 3. So we're just going to keep multiplying 3 times itself until we end up with 243. And if it doesn't, then we just aren't going to be able to simplify this one. There it is, 243. So how many times did we multiply 3 times itself? 1, 2, 3, 4, 5. So it must be 3 to the 5th. When the bases are the same, you get rid of the bases and set the exponents equal each other. Subtract 1 from both sides and you get x equals 4. Because 4 plus 1 is 5, 3 to the 5th equals 243. Okay. Alright, B, let's take a look here. Well, so the first thing we got to do is we're going to go 5 to the 2 minus 2x equals 625 to the negative 1. Now again, we already did this just a minute ago, but let's go. 5 times 5 times 5 equals 125 times 5 is 625. So 1, 2, 3, 4 5s. So since this is 4 5s, we're going to rewrite this as 5 to the 2 minus 2x equals 5 to the, remember it was the 4th, but 4 times negative 1 is negative 4. And now we're going to rewrite this because we're going to cross off the bases. We're going to say 2 minus 2x equals negative 4. We're going to subtract 2 from both sides. We get negative 2x equals negative 6. Divide both sides by negative 2. And we end up with x equals 3. Okay? So A was x equals 4, B was x equals 3. Number 12 is your job.